All right, Dylan, the first thing I wanted to show you was the idea of the sine, cosine, and tangent and how they work with right triangles. And the key is it has to be a right triangle. So I drew two right triangles. Just pretend they're the same size. I know my drawings suck, but they're the same size drawings. And the key is knowing where your right angle is. So if you have your right angle, the side across from it is always the hypotenuse. That will never change. But what changes is the opposite and the adjacent sides. So it depends on where your perspective is or where you're at. So if you're looking for an angle here in this top corner, and you're standing basically at this angle, then the side opposite from you is over here on the bottom, the side that's completely straight across from you. It's opposite. Whereas the side that's next to you over here would be the adjacent. Now, the same triangle on the right-hand side, if I'm standing this time over here in this bottom right-hand corner, then the side opposite from me is across, and then the side next to me is adjacent. So the same triangle can have two different setups. It all depends on which angle you're looking at. So again, if I'm looking at this red triangle over here on the left, and I'm looking from angle X, I'd like to know the sine. I'm going to be looking for opposite over hypotenuse. If I was looking for cosine, I'd be doing a fraction of adjacent over hypotenuse. If I was looking for tangent, I'd be doing opposite side over hypotenuse. Same thing comes from the green one. It all depends on where your X angle is, what angle you're looking for. So if we go back to one of your problems, this is just one of the problems off your page, since we are standing here at angle X, then that means, well, across from the 90 is always the hypotenuse. So we have the hypotenuse A, and they're telling us that that's 26. And then if I'm standing at X, and that means this B over here, it is opposite of me. And then this unnamed side is my adjacent. And they're saying that B is equal to 17. So essentially I need to set up an equation that uses the hypotenuse and the opposite. So you'd have to go back and look at which ones those is. It uses the O and the H. So the one that uses the O and the H, oh, that's the wrong one. That's O and A. The one that uses O and H is here, sine. Opposite over hypotenuse. So that's what I'm going to do. I'm going to do sine equals opposite over hypotenuse. So they're trying to find angle X, so sine of angle X is equal to the opposite, which is the 17, over the hypotenuse, which is 26. And on your calculator, to get that to show you the angle measurement, what you're going to type is inverse sine of 17 over 26, and that will spit out your missing angle measurement. Let me do it on my calculator here really fast and see what the answer is. Inverse sine 17 over 26. I'm getting 40.8 as my answer on that one.